Hello students, uh, today we are going to discuss the topic that is instantaneous center of rotation. We usually call it as ICR. So there are some fundamental things which we are going to learn in this ICR. So before starting, why there is need of ICR, that we will discuss. The ICR is located, that is instantaneous center of rotation is located in order to find out velocity and further acceleration. So this is finding ICR is one of the tool for finding velocity of any link in the mechanism. So this is one of the method of finding velocity of any link in the mechanism. Now this method is based upon the concept that displacement of any link having a motion in one plane is considered as pure rotational motion, and the complete motion is about some particular center, and that center is nothing but instantaneous center of rotation. So whether that link is having a translatory motion or it is having a pure rotational motion, in both the cases it is assumed that the whole link is rotating about a particular center, and that center is called as a instantaneous center of rotation, which is also called as virtual center of rotation. So if you observe this diagram, here you can observe, you can consider AB as one of the link which has moved from its position, that is, and A has moved to A1 and B has moved to B1. During this motion, the motion consists of a pure translatory motion, that is from A1 and B dash, and after that there is a rotational motion about a center A1, that is point B dash has moved to B1. So it is a combination of two motions. One is translatory motion and other is rotational motion. Now if I consider only rotational motion from B dash to B1, the center of rotation is A1. But if I consider a combined motion of point B from B to B1, then what will be its center of rotation? So that center of rotation will change time to time. That's why it is called as instantaneous center of rotation. That will be particular for any position of link in the mechanism. In second diagram, the motion is again consist of two types. It is of two types, that is link is initially having rotational motion, that is point B has moved from B to B dash, and then there is a translatory motion from B dash to B1. So in this case, the instantaneous center of rotation can be found, and it can be obtained as the figure shown below. If I connect point A to A1 and B to B1, and if I draw a bisector from line A to A1 and B to B1, their intersection of the bisectors will be, say, at I, then that I is nothing but the instantaneous center of rotation for that particular link. So here the motion consists of translatory as well as rotational motion, and it's we are assuming that it is a pure rotational motion which is about a center, that is I, which is called as instantaneous center of rotation. Now, how to find out number of instantaneous centers in the mechanism? So number of centers in the mechanism is nothing but it is number of possible combinations of two links. So mathematically we can write it as n is equal to small n into n minus 1 divided by 2, where n, that is in capital letters, is representing number of instantaneous center, while small n is representing number of links in the mechanism. Coming to the next, that is location of instantaneous centers. So in first diagram you can see if there are two links connected to each other by a pin joint, then the instantaneous center of rotation lies at their joints, that is I12 is representing instantaneous center of rotation for link 1 and 2. Second example, if you take, in this there is a pure rotational motion, that is a disc is one of the link, and which is rolling over a surface, that is another link. So its instantaneous center of rotation always lies at a point of contact between disc and that surface, that is I12. If you take third example, in this example, if there are two links having a sliding contact, then the instantaneous center of rotation always lies at infinity, which is perpendicular to the surface over which the second link is moving. So here link 1 is fixed, which I have assumed as a surface over which this second link is moving, which is having complete translational motion, then its instantaneous center always lies at infinity. So these are the various positions where the instantaneous center of rotations lies. These are some examples. Coming to the next point, that is type of instantaneous centers. There are three types of instantaneous centers. One is fixed instantaneous center, second is permanent instantaneous center, and third one is neither fixed nor permanent instantaneous center. So we'll see one by one. Now if I consider a 4-bar mechanism which is shown in this diagram, so there are 4 links. Link number 1 is fixed here. This is your second link, third and fourth link. So if I want to calculate number of instantaneous centers, I can use the formula, that is n is equal to n into n minus 1 divided by 2, which we have discussed earlier. So by this we'll get number of instantaneous centers equal to 6. Out of these 6 instantaneous centers, some of the instantaneous centers will be marked by observation and remaining can be marked using Kennedy's theorem. So what are the different instantaneous centers that can be marked by observation are the first one, that is I12 and I14. So these are at pin joint. So link number 1 and 2 here is connected at point D. So this I12 is a fixed instantaneous center. Similarly, link number 1 and 4 is having a pin joint at I14. So it is also a fixed instantaneous center. So what is fixed instantaneous center? It is an instantaneous center which remains in the same place for all configurations of mechanism. So even if there is a change in configuration in the mechanism, the instantaneous center which remains at its position, that is called as fixed instantaneous center. So generally it is always located to the fixed link. So link number 1 is fixed. That's why the ICR which are related to link number 1 are fixed ICRs. Coming to the next, I23 and I34. So here you can observe I23 which is between the link 2 and 3, that is a pin joint, and I34 is a pin joint between link number 3 and 4. These two ICRs are called as permanent instantaneous centers. So what is permanent instantaneous center? These instantaneous centers moves when mechanism moves, but the joints are permanent in nature. So when the configuration of the mechanism changes, at that time their location is always at a pin joint, that is at pin joint of link number 2 and 3 and link number 3 and 4. So they are not remain at a particular position always. As configuration changes, their position also changes, but it is always at a pin joint between the two links. That's why these are called as permanent instantaneous centers. The remaining two are I24 and I13. The instantaneous centers which are neither fixed nor permanent are called as neither fixed nor permanent instantaneous centers. So remaining all are neither fixed nor permanent type of instantaneous centers which can be found or which can be located by Kennedy's theorem. So these instantaneous centers varies with the configuration of mechanism. So at every instant or when the configuration of the mechanism changes, their position is also changing, and that is called as neither fixed nor permanent instantaneous centers. Remember, during the discussion I always use the notation as I23, I34, I13, I24, I12, I14. So reading instantaneous centers is like this only. You should not read it as I12, I14, I23, I34. So that you have to remember. Thank you.
Of Aronhold Kennedy's theorem. So it states that if three bodies move relatively to each other, they have three instantaneous centers and lie on a straight line. So all these instantaneous centers always lie on a straight line. The proof of same we have already discussed in one of my previous video. So here the diagram is showing the three different linkages. These two rigid bodies are fixed over here to the, I can say, to a fixed link, and these two rigid bodies are moving relative to a fixed body. Now here the two instantaneous centers can be easily marked, that is I12 and I13. The remaining ICR will be there and it will be on this line which will join I12 and I13. So how it is that we are going to see in the coming slides. Okay. So for that we will take one example. The example is of a 4-bar mechanism. There is a 4-bar mechanism. Here you can see link 1, link 2, 3 and 4. A simple 4-bar mechanism is there. We know that for this 4-bar mechanism the total number of ICRs will be equal to 6, and those will be calculated by this formula, that is number of linkages into number of linkages minus 1 divided by 2, and we have obtained the number that is 6. Now out of these 6 ICRs, we know that there are some fixed ICRs, some permanent ICRs, and remaining are the neither fixed nor permanent type of ICRs. So for locating all those ICRs, we need to write down all possible ICRs for this mechanism, and there is a specific method for writing these ICRs. You will see what this method is. So for this, we have to write down the number of links in the mechanism. As you have seen, it is a 4-bar mechanism, so I have written the number from 1 to 4, which is representing the linkages in the mechanism. So we know that an instantaneous center is nothing but, it is, we can say, number of pairs of linkages in the mechanism. So if I want to show all ICRs, I need to write down all combinations of these 4 linkages, and that will be written as the pair between link 1 and 2, that is, it will be represented as I1, 2. Second ICR will be I2, 3, that is a pair of link 2 and 3. The next is a pair of link 3 and 4, which is I3, 4. These are the 3 ICRs. Next ICRs will be written as I13 and I24. These are written as, you can observe the color codes over here. This is the easy method to write down the ICRs. That is, we need to write the first suffix of first ICR and second suffix of second ICR. So here the next ICR is written as I1, 1 from this, and 3 from this, that is I13. Similarly, I23 and I34 gives us I24. So next ICR will be, it will be I14. So it is I14. Now out of these 6 ICRs, by observation we are going to locate the ICRs which are permanent and fixed type of ICRs. So I12 and I14 are the fixed ICRs. If you are able to imagine the diagram which is shown in the previous slide, I12 and I14 are the fixed ICRs. So I will encircle those ICRs, I12 and I14. Next are I23 and I34. These are the permanent ICRs. These are also squared, I23 and I34. Now remaining are the I13 and I24, which will be located by using Kennedy's theorem. So all these 4 ICRs are located by just observation. So in next slide you will see those permanent and fixed ICRs. Here you can see the remaining ICRs are 13 and 24. These are neither fixed nor permanent type. Now how to locate these ICRs? Before that, 1,4, as we discussed in previous slide, 1,4 and 1,2, these are the fixed ICRs because these are nothing but these are the pin joints of fixed link. So 2,3, that is I23 and I34 are the permanent ICRs. Now the procedure to locate these remaining ICR is, you have to draw one circle Now this circle is, you can draw it roughly. There is no need to draw a particular radius circle. This is for construction purpose only. And write down all the numbers, or you can say divide this circle into number of parts, which is equal to number of links in the mechanism. After writing all these numbers, here, as there are 4 linkages, so I have written 4 numbers, that is 1, 2, 3 and 4. I need to join the points, that is 1, 2, because these, if I join 1, 2, it gives a line, and that line represents the ICR which is known. So I 1, 2, here you can observe 1, 2 is known, so I have joined point 1 and 2. Similarly, 2, 3 is joined because I 2, 3 is known here. Next is 3, 4. So here you can observe I 3, 4 is also known, so I have joined it. Next is 1, 4. So here you can observe 1, 4 is also known, which is a fixed ICR. So it is also joined by a line. Now next is I need to find position of I 2, 4. For that, what I will do is, in this diagram, I will join the point 2 and 4 by a dotted line. Now this line is such that it divides this diagram into 2 triangles. So remember, always you have to find, whenever you have to find the ICR, you have to check that whether this line is dividing the diagram into 2 triangles, where the line itself is a common line for those 2 triangles. So here, for triangle 1, 2, 4 and triangle 2, 3, 4, 1, 2, 4 and 2, 3, 4, line 2, 4 is a common line. So this I12 and I14 is nothing but these are the sides of these 2 triangles. Sorry, these 2 sides of this triangle. I23 and I34 are the 2 sides of this triangle. Now let's go to the diagram. If I see 1, 2 and 1, 4, these are on the straight line. So according to Kennedy's theorem, the third instantaneous center will be on the same line. So I need to connect, or I need to extend the line which is connecting 1, 4 and 1, 2, and for the second link it is 2, 3 and 3, 4 which I need to extend. So the line, I need to extend the line which is joining 2, 3 and 3, 4, that is link 3 I need to extend. After extending this, here you can observe the first line is extended, that is I12, I14, and second line is also extended, I34 and I23. The intersection of these 2 lines gives us the instantaneous center I24. So intersection of these 2 lines gives us I24. Similarly, when I want to find out the instantaneous center I13, same procedure will be repeated. So it is connected by a dotted line. Now it is forming 2 triangles, that is triangle 1, 2, 3, triangle 1, 4, 3, for which, for these 2 triangles, line 1, 3 is common line. Remember, the respective ICRs will be I12, I23, here you can observe 1, 2, 2, 3. For second triangle it is 1, 4, I34. Now if I extend the line which is connecting these 2 ICRs, 1, 2, 2, 3, here you can see 1, 2, 2, 3 is extended over here. Next 1 4 and 3 4 is extended, and their intersection is giving me one particular point. That point is nothing but I1 3. So this is the another ICR which is required. So this is how you need to locate the ICR which are of type neither fixed nor permanent type by using Kennedy's theorem. Thank you.